Today we're going to talk about graphing linear inequalities. Really, the big difference between the inequalities that we've done before is now we have two variables, our x and our y, our inputs and our outputs. So I would go ahead and make a table in your notes similar to this. This is a really rough sketch of it, but you need to have a title column, and then it needs to be 5 across and 4 down, including the title row. But we're going to talk about what the solutions on a graph look like for each of these signs. So go ahead and pause the video and get this table ready. So on the first column there, I'm going to go ahead and write line type, shade, and solution, which I guess I should have made that one a little bit bigger, but solution. So the line type for our sign of less than is going to be dashed. And that looks like just a dashed line. And you are going to shade for our solution set. You're going to shade underneath the line. Under. So if the line is here, you would shade here. And the solution set is the shaded region, but excludes the line. Excludes, shaded, and excludes. So that means our dashed line does not include the points on the line. The solutions are not a part of that dash. This is less than. So greater than is also dashed. Also a dashed line. Like so. And when we shade for our solution set, it will be above the line. So if I have a line, we'll pretend it's this way, you're going to shade here, above the line, which those would be dashed lines. But this solution set is just the shaded region. Once again, it's exclusive of, it excludes the line. I should have added line here. Shaded and excludes the line. So it's the shaded region. I don't have space to put region on the other one, but it's the shaded region and not including the line. So now we have less than or equal to. This is going to be a solid line. So just a solid line. To shade it, it will be below the line again, or under the line. So if we had a line like so, we would shade underneath. And the solution set is the shaded region, and it includes the line. So because it's a solid line, that tells me that the solution set includes the points on that line. When it's dashed, it does not include the points on that line. So that leaves us with greater than or equal to. That's going to be a solid line again. And it's going to be above the line. So if I had a line here, then we would shade above the line. and it's the shaded region. And it includes the line. Okay. So this is going to be a good note to kind of help us figure out how to solve when we're given these equations, how to graph, given these inequalities, how to graph them, and then we'll also know how to check them. So I'm going to do a couple things before. I would always kind of some hints. Solve for y, for y to get the slope-intercept form when you're graphing, because that is the easiest one. And then if I would use the table to always kind of have an idea of what the graph should look like at the end. Kind of start off with what it's supposed to look like, and then also remember if it's a positive slope or negative slope, that still stays the same. Just because our equal sign is changed to an inequality, the slope-intercept form has not changed. It's still y inequality sign mx plus b, where m is our slope and b is our y-intercept. So I am going to do this on my paper here, actually. Let me see if I can insert. Do I have graph paper? Oh, there we go. Okay, so I'm going to do number 1 on the practice document for you. You can go ahead and open it up and do it on there. I'm just going to do it on my notes page just to save some time. But the equation is y is greater than x plus 3. So I know for a fact, looking at my table, we're going to talk about what the less than sign tells me. I know that it's going to be dashed. I'm sorry, greater than sign tells me. It's going to be dashed. And I'm going to need to shade above the line. This also means that my solution set is the shaded region, but not the line. I really need to write that in a thinner. Here we go. There we go. It's dashed above, shaded but not line. Okay, so I'm going to draw a graph real quick. Okay, and then I'm going to make it a little bit bigger. So this is 2, 4, 6, -2, -4. This is 2, 4. This is -2, -4. This is my x-axis. This is my y-axis. I always like to label it. Okay, so we know that my y-intercept, the b, is 3. So that's at 0, 3. And my slope is 1. If there's not a number in front of the x, we know it's 1. So I'm going to start at 0, 3. That's a point. And I know that it's a positive slope. So I'm going to go up 1 over 1. I'm just going to continue doing that. I'm also going to go in the opposite direction to graph my point. Now, this is a dashed line. So my line is going to look like, let me go ahead and make that one. So this is my line. And because it's a greater than sign, I know that I need to shade above the line to show my solutions. Because it's an inequality, that means it's a set of numbers. We're shading because we're showing the set of numbers or the solution set that it could possibly be. Now, to double check that we've shaded the right region, I would take a point in the shaded region, not on the line because it's dashed, and I really wouldn't go with the line anyways. But I'm going to pick a point in the shaded region to double check that it fits the solution set, meaning does it make sense? So if I took the point 0, 4, I like to make easy points. So we're going to check our work here. Check. So we have the equation y is greater than x plus 3. So in my solution set, I am using the point, or to check my solution set, I'm going to use the point 0, 4. So I'm going to substitute in those numbers. 4 for y is greater than 0 plus 3. So is 4 greater than 3? Yes. So I know for a fact that this is my graph. I've shaded the correct region. I have my line correctly. I'm going to go ahead and copy this. See if we can do another one real quick. Okay, so I'm going to do number 2. Y is greater than or equal to negative 2x minus 4. So the sign tells me this is greater than or equal to. I know that this line is going to be solid. I know that I'm going to shade above. And my solution set is the shaded region and the line. Shaded and line. Okay. So my M and my B, because it's already in y equals mx plus b, my M is negative 2, my B is negative 4. So if I have my lines of 2, 4, 2, 4, negative 2, negative 4. So my line is at, my intercept is at 0, negative 4, and my slope is negative 2 or negative 2 over 1, meaning I'm going to go down 2 and over 1 every point. So my initial point is right here. Well, let me move those over so they're on the line. That's better. Okay, so my point is kind of at the bottom of my graph. So I'm just going to go backwards, but I'm still creating a negative slope, meaning it's going down. But I'm going to rise 2 over 1 in the left direction going opposite. I could also go down negative 2 and over 1, down 2. I like to fill up my graph. Last point is a little too high. But okay, because it's the or equal to sign, we know that the line is solid. I'm going to draw my line. Let's redo that. Okay. And because it was a greater than, we know that we needed to shade above the line. So this is above. This is my solution set. And I know that's kind of hard to see. Let me go. We can do it in highlighter too. So this is my solution set. That's my shaded region. So to double check that we are shading correctly or we have the right solution set, I'm going to pick a point that's in the shaded region. I like to pick easy points. 0, 0 is a point in our region. So I'm going to use 0, 0. So we're going to check using 0, 0. So y is greater than or equal to negative 2x minus 4. I'm going to substitute in 0 for my x and 0 for my y. So 0 is greater than or equal to negative 4. Is 0 greater than or equal to negative 4? Yes, it is. So we know that that is a correct